Hi everybody, I'm back for the last activity in Unit 6, Lesson 3. It says you write the rules. Write a rule that will transform triangle ABC to A prime, B prime, C prime. So sometimes to figure out what the rule is, I'm going to write the points down. So the original A is 2, 3, and then the new A, you could write it next to it or underneath, is 2, 6. B is 5, 4, and B prime is 5, 8. C is 3, 4, and C prime is 3, 8. So now that we look at that, can we figure out what the rule is? It looks like the x's did not change. But then the y's, what happened to all the y values? You might tend to think of adding first. Oh, I added 3, but that wouldn't work on that one. Right? So how else can you go from 3 to 6? I could multiply by 2, multiply by 2, multiply by 2. So it looks like I left the x's the same, and then I multiplied all the y values by 2. Are A, B, C, and A prime, B prime, C prime congruent, similar, or neither? Okay, well, we just talked about this a minute ago, and maybe we should write this down somewhere. Transformations that produce congruent figures are your translations, rotations, and reflections. That's how you get congruent shapes. To get similar shapes, a dilation. A dilation blows up both the x and the y, or it divides it, and that's a dilation. And if it's not one of these or one of these, well, then it's neither. So what did this do? If I only multiply one coordinate, is that a dilation? No, a dilation, you have to multiply the x and the y to keep the sides proportional. That would write your definition as similar. So neither. I only multiplied the y by 2. The sides are not proportional. Okay, moving on. And the angles wouldn't be preserved either. Number 3, write a rule that will transform triangle DEF to D prime, E prime, F prime. So this one, you might be able to do this without writing the points out. I'm going to get a pen for this one. So I can write it right here. D was negative 2, 1, and D prime became negative 2, negative 1. E was negative 4, 3, and E prime became negative 4, negative 3. F was negative 6, 1, and F prime became negative 6, negative 1. What happened here? The x's did not appear to change again, but then the y's, they changed their sign. 1 became negative 1, 3 became negative 3, 1 became negative 1. So it looks like we took the point x, y, we left the x the same, and then we just changed the sign on the y. Now you might not have known if I just would have shown you this, what that was, but when you look at that, that's a reflection, right? A reflection across the x-axis. And a reflection is one of our rigid transformations. So I know that those two shapes are congruent. So I'm saying it's congruent because it was a reflection. which is a rigid transformation. The word rigid means it maintains everything. It stays the same. Okay, let's just wrap up now with the lesson summary. Here they show us a triangle, DE or ABC, and they show us two different transformations. They do this one, which is where I switch the x and y, and I changed the new x to the negative. And then on this one, I left x the same, and I multiplied the y coordinate by 3. You can see with your eyeballs that those two aren't congruent, right? Maybe you think they're similar, but in order to be similar, a dilation, you have to multiply both the x and the y. And we pretty much wrote on the previous page which ones produce congruent figures and which ones produce similar. In order to be congruent, it needs to be a translation, a rotation, or a reflection. And also on this one, if you can't tell what's happening, let's look. Draw A to the center at 0, 0, and A goes to D, right? Can you see that now? That's a rotation. You could do it with any of the points and it'd be the same. So this one is congruent to it. This one is not congruent or similar. Okay, you've got some practice problems. I think you're doing 1 through 4 and number 6. And there is a video in there to help you if you need it. Have a great day.